good afternoon, and good evening, everyone. Before I begin, I want to take a moment to thank HashiCorp for giving me the opportunity to speak at HashiTalk. Securely building. It's such an honor to be here with this amazing community of builders, security professionals, and innovators. Today, I'm going to share something I'm deeply passionate about. How we can move towards what I'd like to call secrets without secrets, using federated identity across AWS and Azure. Before we begin, let me introduce myself. My name is Rahul Raj. I have 10 plus years of expertise in IT industries. I have played multiple hats, so as a solution architect, consultant, and now I'm playing positioned at DevOps manager at Autodesk. Let's start with the scenario I'm sure many of us have lived through. You open a code repository, maybe one of you haven't touched in months, and there it is, untucked away in a configuration file, an AWS access key or an Azure client secret. Sometimes it expired, sometimes it is still valid. Either way, it is a security risk, just waiting to be exploited. This problem exists because in traditional cloud setups, we rely heavily on static credentials, static secrets, API keys, passwords, database connection strings embedded in code and configs. They are long-lived. They get leaked in logs. They are hard to rotate without causing downtimes, outages. And once someone has them, they have got the keys to the kingdom for a long time. But imagine a different world. One where your application stores no secret at all. Instead, whenever it needs an access to AWS or Azure resources, it proves its identity and gets just-in-time, short-lived credentials. Credentials that automatically expires quickly, sometimes in minutes. That is secrets without secrets. And the technology that makes this possible is federated identity. And right in the heart of that solution, we have HashiCorp Vault acting as a central identity broker. Here is a big picture. Workloads authenticate to Vault using their identity from a trusted source. Vault exchanges that for short-lived credentials from AWS or Azure, and no static secrets are ever stored in your code or environment variable. How secrets without secrets actually works, right? Let's quickly unpack the core ideas behind before I show you the magic in action. Dynamic credential issuance. Vault can generate ephemeral credentials on demand. AWS and Azure trusts Vault to mint these credentials, and they come with a short TTL. Or so even if someone gets hold of them, the window to misuse them is tiny. Federated identity with OIDC. The glue that makes multi-cloud federation possible is OIDC, OpenID Connect. It's an identity standard that lets Vault prove a workload's identity to AWS and Azure without secrets. Instead of a static key, we use an identity token exchanged securely for cloud credentials. Multi-cloud and zero trust. This works across providers, meaning you can have a common identity strategy for AWS Lambda, Azure Functions, Kubernetes bots, all with a consistent authentication flow. It follows the zero trust principle. Never trust, always verify. Every credential is short-lived and workload specific. Quick question. Who here has never stumbled upon a secret in a code base? Maybe I am. Exactly, right? This is why we need to rethink secrets management. What you will see in the demo. All right, so now that you see the why and the key concepts, let me give you the roadmap of what we are about to do, right? In this demo, we'll set up Vault to federate identities with both Azure and AWS. First, in Azure, workloads will authenticate to Vault using Azure AD issued tokens. Vault will then dynamically create Azure credentials from them. Then in AWS, we'll switch to AWS. where Vault will act as an OIDC provider itself. AWS will trust Vault's identity tokens to create short-lived IAM role credentials. Again, no long-term keys anywhere. We will watch credentials being requested on demand, used, then expiring. No secrets stored, no rotation headaches. Let's roll up our sleeves and jump into the demo. I'm going to follow a GitHub README file, which will be shared across with you post the session is over. And in this README file, I have documented every steps and every commands which someone can follow along and configure these with Azure and AWS. Couple of prerequisite items which you need to follow. I'm using HashiCorp Cloud Vault cluster for Azure configuration and a demo, and I'll be leveraging ngrok. I'll be initiating a Vault dev local server for the AWS demo. Do note that you might need an enterprise license in order to use Workload Identity Federation. You might need Azure subscription, an AWS account, and obviously, so an ngrok. So ngrok is an application or a tool which points your local host to publicly resolvable DNS endpoint. You might need other packages like jQuery, OpenSSL to configure SSL, Azure CLI, and AWS CLI. Because I'll be doing everything programmatically and a couple of things on the console to show you how things on setups looks like. So this is my Vault cluster, which is up and running, and this is my public endpoint. This is my private endpoint. So let's try and configure it for Azure first. So I have my own subscription. I have created 2 app registration, and I'll not deep dive into app registration detail. So in the app, I have 2 app registration. One is Vault Azure, where we will try and configure Vault with client ID and client secret first and see how things are work. And then we will get rid of that and set up our Workload Identity Federation within Azure app without client secrets. So I'll open my terminal, and I have set things up before. So I'll just walk you through with the environment. Couple of environment variable. What you might be needing is your Vault address, the cluster address, which you can grab it from HashiCorp Vault console portal. You might need to generate a Vault token, which I'll be doing in a minute. So here is the Vault generate token, and you can generate a new token from here. So I just generated 1 token for me to use and copied it, and I'll be just replacing my token in the configuration file. Okay. Once you have this token generated, you need to also export your Vault namespace. So anything which is running inside HashiCorp Vault Cloud, by default it gets created in admin namespace, and we do not have much control on the admin namespace. Next, what we will going to do for this demo, we will create a different namespace, HashiTalk, and then we'll use that namespace to create our configuration and everything together, right? This is how an Azure integration, like for this static credentials, if you want to configure static credentials for Azure Secret Engine, you need to enable Secret Engine first. Then you have to set up your Azure configuration. This is one way of doing it. This is using the static credentials, right? Where you'll be leveraging subscription ID, tenant ID, client ID, and client secret. In this case, what I'll be doing, I'll be leveraging Vault Azure, as you can see on my portal. Let that come up. I will create a client's secret, and I'll be leveraging that client secret to configure the Vault Azure configuration, and then we will try and generate the credential first. So this is, and then I'll be just creating a role with the object ID and try to read this. So this is how traditionally somebody selects and configure their Azure configuration or integrate Azure Secret Engine, right? So let's roll up to the terminal quickly. And here on my terminal, I have already created some script, which I'll quickly show you as well, so that I do not write these codes. I'll be sharing these codes on the GitHub repository. So first, let's go with Azure Secret Engine. here I'm just what I explained. I'll be replacing this token because this token is will be expired in by the time you will watch this video. So no worry, don't worry about it. And what I copied the subscription ID, tenant ID, client ID, and client secret from the particular Azure app which I just shown. So most of the details you will get in the overview section of that particular app, and the client ID and client secret what you will be getting. So you will get all these details. Once you have this detail, it's pretty much simple. You enable Azure Secret Engine, you give your client ID and client secret, and boom, you should be done. So let's try and execute this. And if everything goes right, it's going to configure Azure Secret Engine for us with client ID and client secret embedded into it. So as you can see, it created a new workspace, admin HashiTalk, and then you can see that the ID of that particular admin namespace is this. It then enabled Azure Secret Engine at Azure. It then tried configuring Azure configuration, which I'll show you using this particular command, and then it created a role, and then it tried to create a role. So basically what happened here, if you see on the portal now, and if I go to client and secret, you can see that this particular client ID and secret are what I used to configure this engine. And when we tried reading this particular credential which was created using the client ID and client secret, it created another client ID and client secret for you, right? So, and let me command which we ran, which generated credentials for us with client ID and client secret. We have another plugin, Secrets, which was created for that use case. Inside Vault, you will see that one Azure mount path which is created just for this use case. Now let's move on to how can we switch to Workload Identity Federation, right? Here we were using a client ID and a client secret for our configuration. Now for that, let's look into our OpenID Vault configuration, which we need to set up the Workload Identity Federation into our Vault portal Azure app. So you will get this endpoint from the public endpoint, and in this public endpoint you need to append identity OIDC plugins, well-known OpenID configuration. When you hit this particular endpoint, let me take the cluster endpoint. This is going to be the cluster endpoint, and then Vault URL I should be replacing. When you will hit this endpoint, you are going to get an output of OpenID configuration. And what we are most interested in this, one thing that you need to consider that the endpoint which your Vault is set up with should be a publicly resolvable TNS in order to Workload Identity Federation to work. We are interested in the issuer URL, and this is what we are going to set up and use for our Workload Identity Federation configuration. Now for this, what I'll do, I will be using a different app which I just told. So let's go to Intra, Microsoft Intra, app registration. By the time it's loading up, I need to clean up my Azure configurations as well, so that we can work through for the next one. So what I'll be doing, I'll just disable the Azure mount path what we created, and we'll re-enable it and then configure the Vault again. So let me just quickly do this. All right, I think I'll have to log in here. So anyway, let's log in. That's not a challenge. Let's log in into, let's set this address, or let's do this. Let's let's delete it from here. Let's delete it from the terminal, right? So what I can do, I can just go to secret engine and let's disable it. And there you go. All right. And what we will do, we will just enable the secret engine once again for Azure and enable. So this is getting enabled at admin task, and what we need is the ID of this particular secret engine. Hopefully this is came up. So in the all application list, now we will be using Azure Workload Identity Federation app to configure it. Now here, if you see, you will not find any secrets configured with this particular app. And just for for the simplicity and to understand that we are not mixing both, I used a different app. So you can see there is no client secret and client ID here. Instead, what we are doing, we are leveraging this federated credentials. You can add credential. I have already created one credential here. So you can just, I will show you the configuration of it. You can select in the federated credential scenario, you have the multiple option. You have to go to other issuer. This is the issuer I was talking about. So this is what the endpoint Vault Azure would be sending requests to, and this URL is built of your cluster endpoint followed by your v1, and then this is your namespace. So namespace is mandatory. If you forget to namespace, you might not be able to connect. And then identity OIDC plugin. Type, you can keep explicit subject identifier. Value, in the value format is plugin identity is hard coded. Then this is the ID of your namespace, where if I show you in my terminal, the moment you will create the namespace, you will get your ID. So I'm going to replace this with my newly created ID. And here I need the Azure accessor ID. So I'll just go ahead and grab the accessor ID of my Azure secret engine, which is this, and do the configuration here. That's it. This is it. And the name can be anything. You can write it. Audience, you can leave it as it is, and you can just create. And for me, I'm just updating it. This is done. So this is the configuration what you need to do on the Azure app for this to work. From the Vault, let's go back and switch to our README file. Now, in order to work with workload identity, here if you see that, again I'm going to export client ID, tenant ID, subscription ID, but here I'm not importing or exporting the Azure client secret, which is not needed in this case. And then I'm going to do the similar configuration again here. No tenant ID, no secret ID, which I'm mentioning, but instead this is a mandatory audience which you need to mention, which is going to be Azure AD token exchange. This is going to be similar looking what you had set up in your Azure Workload Identity Federation. And that is it. Once this is done, you should be able to access it. Let's run it, and then we'll see how it goes. Well, I'm on my terminal again, and I'm going to run another script, which is Workload Identity Federation, and then let's see. Okay, Azure configuration data is written, Azure roles is created, and boom, there you go. You got a client ID and a client secret, and this time we did not use Vault client secret. And if I go to my Vault, and if I just reload this Vault configuration, you should be able to see the configuration of your Azure secret engine. Right, it's loading. Here you go. You can see that identity token issuance, this cluster issuance, issuer is this, subscription ID, tenant, and client ID. That's it. You are not worried of secret, and now you can exchange a token with Azure to get you client ID and client secret, which is short-lived, and you can revoke it when it's not needed. That's for Azure. Let's switch our gear and move towards AWS. How is it possible for AWS, right? So for the AWS workload, I'm not going to use the HashiCorp Cloud Vault. Instead, I'm going to set up a local dev server with and using NGRock. I'm going to expose my local endpoint to publicly resolvable endpoint, and let's see how we can do it. Once that is done, there are certain configuration item which we need to do. For example, you need to set up Vault API address, which will be pointing to your NGRock forward, the address. Let's see, and then you will be able to understand. So I have opened 3 terminals here, which you can see. In the first terminal, I'm going to use NGRock and redirect all my traffic, localhost traffic for 8200 to a publicly resolvable endpoint. So now this is going to be my new publicly resolvable endpoint, which will resolve to my 8200. Using this endpoint, I'll be initiating Vault dev server. And how can I do that? Let's see. So let me set this up. I have written a lot of commands, sorry for that. So this is the API address which I'm going to replace here. The new API address is going to look something like this. And here in this particular path, I have a Vault Enterprise license. So you might need a Vault Enterprise license for in order to configure this with Workload Identity Federation. And I am also setting up access key and secret access key initially just to interact with AWS, and then we will initiate the server Vault, right? So let's see how does it look like. So what I'm going to export all these into my second terminal. I let this keep running. Let me clear the screen, and here you go. And next, let's initiate the Vault's dev server with where I'm saying that initiate the Vault local dev server with root token as root, and this should bring up the Vault dev server, and I should be able to reach my dev server using the endpoint which is given by NGRock. For example, if I have to show you, I can resolve this endpoint now on a public URL. So you can see that it might give a warning first that you are accessing site which is free. That's true, and you can see that now I'm able to see the Vault Enterprise here. I can see the UI now. Though I'm not going to log in, I'll just close this terminal up. Once we have this NGRock running and Vault dev server setup, what I can do, I can try and export the Vault address and see if the Vault is really resolving. Let me copy this new endpoint and paste it here so that I can use it. So what I'll do now, I'll use a third terminal for this. I'll export the Vault address and the Vault token, and I should be able to get the status of my local Vault cluster, right? And you should be able to see that what's happened. First path segment cannot colon. Okay, I think there is some double equal to. Let me remove that and then paste it again, and I should be able to see the status of my Vault cluster, hopefully. Yes, here you can see. So I'm not running a binary open source binary. Instead, I have an enterprise binary with the license, which is going to expire in some days. So you need to have that enterprise license in order to use this Workload Identity Federation. So now what I have done so far, I used NGRock. I redirected my localhost port 8200 to a publicly resolvable endpoint. Then I initiated my Vault dev server on a local host, and this is how my cluster looks like. Let's move back. Once you're done with this, you may need to prepare OIDC thumbprint and metadata to configure your OIDC endpoint or OIDC configuration for AWS. So what I'm doing basically here, I'm just generating a domain. I'm fetching the domain from this well-known OpenID configuration, which I just was talking about while doing the Azure configuration. Once you have the domain, I'm using OpenSSL certificate, OpenSSL command to generate a certificate, and then generating a thumbnail, a thumbprint for that particular certificate to configure it. And I will quickly show you where and why we need this, right? Once we have this, we are also going to create a role and a trust policy, which will be used to assume that particular web identity federation and help you generate the credentials or create IAM user or whatnot. And these are certain permissions which you might be needing at minimum to get away and get started with this. So I have documented everything. All the commands are going to working, and I'll show you how does my AWS accounts looks like. Now this is the place where you do your identity configuration for AWS. So you go to AWS console, you go to IAM, and then on the left panel you select identity providers. So now you can see that I do not have any identity providers at moment. For validation sake, I will also show you there is only one user right now. There is only one user right now in the IAM, which is my user, which I'm using for this particular demo. And if you see, there is only 4 to 5 roles which is created because we'll be creating a role, so you should see and understand. So there are 4 roles what you can see in my console. Let's see. So let's go back to our IDE. So this is all AWS command. So what I'll be doing, I'll be just doing the configuration for AWS first, where we'll be creating OpenID connector, set up a role and everything, and then we will move on to setting up Vault. Let's go back to our terminal. Let's clean this up and execute the command. So I have noted down the command as well. So this is very simple. I'm setting up AWS. I'm passing my the new endpoint of Vault. I'll have to copy and replace this, otherwise it's going to throw an error. Let me do this as well. Okay, and let me just run this. What it will do, it will connect to my AWS account. It will create role. It will set up identity broker, and it's going to create that is that, create policy and then attach it with that particular account, right? And so while this is working, let me go and show you in the AWS console what's happening, right? In the AWS console, if you see now, I just refreshed roles. I think the roles are still being created, and soon we should be having a role. Yeah, so you can see that there is a role which is now created, Vault AWS Secret Engine, and we should also have an identity providers created for that particular Vault endpoint. So still working on it. Let's reload this page. Okay. Come on. All right, here you go. So we have an identity provider created and set up for AWS. You can see that now this is the identity provider. There was nothing, and now if you can see, you can click this identity provider and you are all set. So you have an audience can be anything, any text, but you need to make sure that this is same configured as part of your trust. Endpoint verification, as I told you, the thumbprint which is created in order to validate, so you can add up to 5 thumbprints. This is your provider. So we are all set from AWS side, and you can see in the user section we still have only one user, that is my user. Right now, second step, let's try and configure Vault side of it. Right, So configure vault. What we're gonna do? I've just written a program code for this as well, just to speed up the execution. We are going to export the root token address. We are going to configure identity OIDC configuration and set the issuer URL. We are going to enable secret engine. We are going to configure, and you can see that we are not using any access key and secret access key to configure the root credential. Instead, we are using the token audience and role ARN, the one which is created above. And then we are going to create a role, and based on that role, we should be able to grant read permission for that. Let's see. All right, so for that, what I have done, I've created a script where I'm just passing the vault endpoint and the role ARN which was created. So let me clear up this and then just run it. So this will enable AWS secret engine for us. It will set up the issuer URL for identity plugin. It will configure AWS root, and then it will create a role, and it will try to read that particular role using IAM-Crit. So here you go, everything works fine. Now you can see in the terminal, if I refresh it, here I'm not using assume role, I'm using an AWS IAM credential, IAM user type of credential. So you can see that there is a vault token which was created without giving any sort of configuration. So you can see that if I just do vault read AWS config root, I should be able to see. So the role is configured, identity token audience is configured, rest of thing are not here, right? There is no access. That's pretty much it. So if you have any questions, feel free to reach out to me on my GitHub page or on my LinkedIn, and I'll be happy to connect and help you out. Thank you so much, and thank you for listening me. Have a good day.